Greetings, everyone. Yiannis Palaiologos from Kathimerini and Inside Story. Lovely to be here in this blustery spring morning. Now, we're going to be talking about visual generative AI in this next session. To a nostalgist of the analog age like myself, this immediately has connotations of malign global actors trying to manipulate global public opinion, of fraudsters with powerful new tools to defraud you, of artists screaming about copyright infringement. But after speaking to our next speaker, Gal Chechik, an amazing scientist, I realized there's also actually a positive side to the whole thing. So Gal, who is a senior director for AI research at NVIDIA, one of the world's most valuable companies, and also a professor at Bar-Ilan University in Israel, is going to talk to us about this positive side. Then he's going to face my severe and extremely difficult questioning, and then also take some questions from you. So the floor is yours, Gal.
Hi, everyone. Aiming for a positive view of what we're doing. Oh, there it is. So, okay. So, I am a researcher at NVIDIA, and I'm leading a research group, the research team in Israel. And I want to tell you about some of our thoughts and approaches to generating visual content, and perhaps some insight from these creative processes will also help us think about creative or creation in other areas like science. So we talk a lot about vision and language, but actually these are like two different domains, two different spaces. And the technical terms in machine learning, we have something that maps from vision to language, discriminative models, and we have things mapping from language to vision. But when I say vision, I actually mean something much broader. So these are images and videos and anything actually which is things in the world, everything that we can perceive in the world. It could be sounds. And on the right side, language is much more than language. This is just like an abstract representation of the world. So we have ways to take the world and understand it, map that to our thought, or our model of the world. And we have the other way around, where we take our thoughts and we imagine what the world would be like, or perhaps build that even. So I'm going to talk about this other direction. But the two directions, the understanding and the generation, are together. There's an observation that I think is very useful when you think about creation. And that is, we should realize that if you look at stuff in the world, their distribution is very unbalanced. There are some things that are very, very common. There's a few things that are very common. Like if you go outside, you see trees and buildings. And some things are really rare. And for AI systems, they're trained on massive data sets. So it's easy for them to handle the few things that are very common. But there's a growing and growing challenge as you go and try to do things that are more rare. So perhaps even the model has never seen them. And perhaps we're going to talk about it later in the discussion. So on the left side, the rare things that you perhaps never see, the dodo and the payphones. And when we come to design systems because of this imbalance, there are actually two types of approaches in AI. One is more statistical, where you look at a lot of patterns of data, and there's, when you look at the long tail of rare things, then you need other approaches. And perhaps some of you know this book by Nobel Prize winner Daniel Kahneman that talked about our cognitive systems. And our cognitive systems actually face the same challenge. And he suggested you can think about human processing, human cognitive processes, as having these two systems. System one is fast and intuitive. You can, when you get asked questions, like the first thing that comes to your mind, or when you observe something, it's the first thing you recognize. But there's also system 2 that is designed to solve more complicated challenges. Perhaps you need to do a lot of longer thinking. And what we see recently, both in large language models and also in vision, in generating images and visual content, we also see these two approaches, and I want to tell you about a few such example cases. So just very quickly, I'm sure you all used all this text-to-image generation, or you tried that. Here's how it works, how people generate or create these systems. You take an image, let's say, of a cat, and you add noise to that until you have image that is fully noisy. And now you basically learn to take something that is noisy and reduce some of the noise. So after you train that, you can just do re-noise, 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 and you start from noise and get a cat. So this is how these systems work. So these systems, I'm sure you play with it and you try it, but there are a few things that you want to do and they are still not working or pretty frustrating. So I wanted to show you a few examples. So the first thing, this system you can create really fantastic images, but sometimes you want to create images of your things. For example, this is Max, this is my dog, it's a beautiful dog, but it's not very smart. So perhaps I want to make images not of some generic dog, I want to make images, create images of Max doing complicated things. So this is for personal pets or family members. Perhaps if you have a company that produces toys, you want to make advertisements of your product, not some generic product, right? So what we did was, the idea was that we teach the model just a new term. We do that by showing just a few images of Max, and we change the model, we retrain the model very slightly, and then once the model learns who Max is, you can do new tricks. You teach this dog new tricks, so now you have Max reading a book or Max cooking a meal. And the point is that what the model now knows to do, it takes everything it learned from all the data on the web and combine that with my Max. So this is one process called personalization for text-to-image generation. Now, there are a lot of other issues today with these models. Here's one problem. You ask them for, let's say, a yellow flamingo with a pink sunflower, and you get a pink flamingo. Because the model only has seen pink flamingo, so it's hard to convince him to do something he doesn't know. Or another example, counting. You ask for Snow White and 7 dwarfs, you get tons of dwarfs. These models don't know how to count. Because counting, if you think about it, it's not a simple process. It's not just like an intuitive process. You need to do some real thinking, going over the image, and doing that while you generate, it's a complicated process. Also, perhaps you want to generate some images of the same character. You want to tell a story with characters. So let me just show you a few things that we can do today. These are these examples where you have the pink flamingo instead of yellow, or you ask for a lion with horns and the model just ignores you. And the idea is that while we generate these images, we add another process of thinking. So the model starts to generate something, and then it fixes what's not going well. So it cleans and fixes, cleans and fixes. So kind of this thinking while you create the image. And indeed, this gets you the yellow flamingo that we wanted. Here's another problem that a lot of people are frustrated with that. So I just went an hour ago to one of the, this was OpenAI, but all the text-to-image generator have the same problem. And I asked for an old man with a hat walking in a park. But let's say I want to tell a story. I want to take this person and just tell a story about this guy. And I ask for now create the same man, drinking beer. But it doesn't give me the same person, right? It has a different hat. It looks different. And I really want to tell a story with the same guy, right? So I told you before that we could teach the model a new character. So if you think about an artist, you can show them a few images of that character and they will really learn how to do that. But that process will take a long time. We can do that with AI models, but it would take hours. But there's another trick that we can do. If you just ask an artist, please generate 2 images of the same character, what they will do is while they're drawing, they will, look at both images, look at the character, and make sure it looks the same. So we actually have this trick, and we teach the AI to do something similar. So while we generate, and we don't need any training, while we generate, we make the character consistent. So these are examples from our model. You have the same character. This guy is walking in a park. And you can tell a lot of interesting stories. You can have characters and objects. You probably see what you have on the middle row. You just ask for a girl with a red hood and a wolf, and you get the whole illustration for a book. Okay. Now, another problem, and recently, probably all of you have seen this impressive text-to-video. And this was one of the videos that was released when Sora was released. And people were really excited. I'd like you to watch the feet of this person walking. Maybe I'll show you. Let's do that again. So it looks amazing, looks really realistic, but at some point, maybe now, have you seen that? It switches the legs. So these models, it appears as if they learn the physical reality just from videos, but they don't. And of course, we want content to be physically consistent, right? So how can we do that? And one idea is we can start with a simulator. This is a very crude simulation of a person, just a stick figure, but we train a model to control the joints of that model, and
nice to meet you. I'm a masked mimic.
Oops, could you shut yeah, we don't need this. Good, great. So what we do, the model here looks at a lot of motion capture, seeing a lot of people walking, and then you just control it. You tell it, hey, move the head. Perhaps you see there was a green dot telling it how the head should move, and the model fills in all the other movement of the body. And even if you train that on a flat terrain or a different environment, the model actually knows how to walk in different terrains and do different movement. And you can make it now do fun stuff. On the right side, it can actually do cartwheel, which it never learned to do, and it looks reasonably realistic. So this was like a very crude rendering, and now you can use videos. You use that to control a video generation. And here you get this guy doing graffiti. You can actually control what they're going to write on the wall if you want, because you just control the hand and the rest of the body will follow. Now, I talked a lot about visual creation, visual creativity, and I focused on this problem of the long tail of things that are new or hard to do or the model has never seen. And these ideas are probably transferable to other domains, like if you think about science. So in science or technology, we often try to imagine what we want to build, right? We kind of explore the space of ideas. And there's a lot of thinking of how to use generative AI for developing the process of science itself. So thank you so much. Few more examples. These are just replicate of our robot guide. So he learned that whenever there's a couch, it just automatically goes and sits on it because that's what it saw in the training data. That's it for now. Thank you.
Thank you very much, Gal.
Thank you.
I should mention that you can use the Slido app, which there will be something in the big screen behind here soon, I hope. Or if that doesn't work for you, you can raise your hands and ask questions in the old-fashioned way after my questions. So you mentioned there at the end the sort of the beginnings of the idea of generative AI helping with the actual process of scientific research. Can you tell us a little bit more about that, how that would work, and is it something that you've already incorporated into your own working methods?
I think this is very early, and I'm talking about just these are thoughts about thoughts that people have about the process. So we do see a lot of tools coming, trying to help scientists to be more productive, the same way you see coders being more productive. And these tools come from generating ideas, help brainstorm. If you're a scientist, you can brainstorm with the LLM and go back and forth. Sometimes it can run code and help you create experiments. And it's an interesting question. How can we accelerate the progress of science? Because science is a very slow process. You should be very careful and very meticulous, right? And a PhD takes years and years. So can we achieve more faster?
Is there a concern of outsourcing too much to the intelligent machine? I.e., you know, if it does many things very well, then a scientist may be moved to outsource that to it, and then he or she will lose their own abilities to do those skills will fade, let's say.
I don't think so. I think actually, if you talk with scientists, most of their time is not spent on the scientific rated process. It's on things that perhaps can be accelerated.
Okay. Now, we're all familiar since a couple of years ago with chatbot, AI chat models. But is there something you can tell us about new models of chatbots that focus specifically on healthcare? Is that something you've worked on?
Yeah. So that's a great question. So large language models, everyone knows all these chatbots. They are trained, they view language as a sequence of words. And there are a lot of scientific signals. There are also sequences. So for example, we took data from a continuous glucose monitoring. There's like a patch that measures your glucose level, or an estimate of your glucose level every 15 minutes. So now you have this pattern of how your glucose changes, especially when you eat or when you exercise. And these glucose patterns have tight correlations with a lot of health measurements, even clinical measurements. So it turns out you can train a model, the same type of models that you train for language, you train them with using the same techniques on these patterns of glucose, and you learn to something that allows you to predict various clinical measures much more accurately than we could before.
Okay, that's fascinating. Now, you have also mentioned in our prior discussion the way in which, I mean, obviously we've all heard about things like deep fake videos and so on, but on the other hand, you were keen to highlight the way in which this technology, as it becomes better and better, more and more sophisticated, can have an enormous positive impact on business in terms of the kinds of simulations that are needed to perfect designs and so on and so forth. And this could make for a much better and more streamlined process of production and manufacturing. Can you tell us a bit more about that?
Yeah, that's right. So, you know, we start text to images, having cute photos of dogs and cats. It's great. You know, it's for creation, it's fun. But generating visual content has really far more useful applications. So if you think about it, once you move from generating still images to generating dynamic images, videos, or 3D scenes, or physical worlds, we can generate simulations of worlds, then it becomes really useful, because everything you want to build, everything you design, you want to design that in simulation first. If you build a room, if you build this ball, you want to design it. If you build a room, you build a city. So at every level, you want to design in virtual world, and this would make everything much more efficient, right? So there is a second level to that once you can simulate these worlds, you can actually use that to train AI models in these worlds. We all know that we heard about autonomous vehicles for so many years, And this is much slower than we expected. And the reason is that there are always these rare events, these long tail events, unexpected things that happen. And for us, people are really good at handling unexpected new things, but these AI models are not that so much. So
the simulated worlds could help with that kind of training in a safe environment, let's say.
Exactly. And clearly you don't want to deploy a car that is not ready outside. This is dangerous, right? So one thing that people do is you generate some simulated environment and you train your autonomous vehicle or robot in this safe environment. But of course, it should be realistic. It should be physically consistent, because otherwise you train in the virtual world, and once you test it in reality, it's going to fail. So this is true for autonomous vehicles. It's also important for physical AI if you want to train robots. So, and by the way, here the challenge is often not just interacting with the world, but even just moving the robot in a consistent way. It really helps if you train that in a simulated environment.
And is the visual AI technology there yet in order to create these kinds of environments?
Yeah, because what you want to have, if you want a robot in a factory, right? It needs to react to what it observes. So you really need to generate simulations that are perceptually realistic. Otherwise, you'll have this what's known as sim to real gap. You train in simulation, but there's a gap from reality, and it fails when it goes out the door.
Reality ends up being more complicated than what was captured in the simulation.
Yeah, both more complicated and sometimes just different. Imagine that you only see one type of bottle in your simulation, and now you see a different bottle. So these AI, they are much more brittle than people in generalizing to new things.
Okay, now another thing I wanted to discuss, which has been kind of the big global story this year when it comes to generative AI, is what happened with DeepSeek, the Chinese model that came out a few weeks ago, caused an enormous stir, a major market sell-off, because apparently the company behind this model was able to produce it at a much lower cost, much more efficiently. A few weeks down the line, when it comes to the talk in the community of the people who produce this technology, like yourself, is there a sense that this really was a game changer, or were some of the early claims overhyped, and perhaps there was a bit of a market hysteria which was only temporary?
Yeah, it's a great question. I think there's some very interesting trends going there. So first, I don't have information about DeepSeek besides what they released, but there is something really interesting about the direction of and type of problems and type of compute that this reveals. So DeepSeek released this model. It's called R1, and R stands for reasoning. And what we observe is that these models start to work on problems that they couldn't do before. And what is this reasoning process? And this is related to something I mentioned in my talk, the System 1 and System 2. For a long time, our AI models were kind of fast systems. You give a question, and they immediately just give you the next word, and they build the next sentence. And this is good for some cases, for some problems. But there are a lot of problems when you try to solve something. Think about chess. If you want to play chess, then at every move you have a lot of possibilities. But to win the game, you need to see several moves forward. So the number of options just grow 10 times, times 10. So the number of options grows exponentially. So what this means that in reasoning problems, there's a much larger demand to compute. And we only now start to be able to address these very complex reasoning problems. And they actually have a really interesting figure in their paper that shows that, and they test this system on some problems, let's say math problems. And what you see is that they let the model think further and further, kind of open the tree of possibilities. And you see how the quality of their results improved when you let the model think more. And you clearly see...
And it's more transparent about the way the model is reasoning, right?
Yes, yes. And so you can see the model making all these steps of thinking. And sometimes, and that's what people do too, right? You have a line of thought and you ended up in somewhere wrong. And you need to go back and start, right? So the more paths like this you do and the deeper that you go, you get better results. So what this means is that there's going to be a really much higher demand for compute. It's somewhat different, this what's called inference time compute and training. So we used to invest a lot, we just train this model to give the first answer, right? And we train them to do that. But now, in addition to that, they also need to do deeper thinking. And this would require a lot of compute, of accelerated computing, GPUs, networking, and there's a lot of compute demand.
So there will still be a lot of demand for NVIDIA's chips.
Yeah, I think but what we see is that adding more compute actually helps get better quality and solve new problems.
Now, I want to turn to the audience in a minute, but I wanted to ask you one last thing, a sort of big picture biographical question. I mean, before you went in to do your PhD, there was a period which has colloquially been known as the AI winter. Then, in the last couple of decades, seemingly with exponentially increasing velocity, that technology has really taken off to the point where we're now talking about the imminent arrival of artificial general intelligence. Can you tell me a little bit about how you experience this, whether you think the continued upward trend, the continued evolution is inevitable, whether you think AGI really is coming and what that would mean in like 35 seconds?
It's hard to predict the future. The field of AI, went up and down, winter, and I think we are still see a lot of progress now, opening new problems, addressing new problems, and it's clearly not slowing down. There's a really still huge potential.
Okay. So, another anonymous question here from the audience. I would urge you to use your names, why not? And this person is asking you, Gal, why are AI-generated images distorted or have weird characteristics, for example, distorted eyes?
Yeah. So I think what really happens with this model is that they're, again, very good when you ask them to draw something that is common and that they are very familiar with. But once you try to push these models a bit outside of their comfort zone, they simply don't understand well what we want.
I'm like that myself.
What's that?
I understand. I'm like that myself.
Yeah. So at some early point, it was very common to have distorted hands. There were all these images
Extra
with
fingers, right?
extra fingers. I actually saw once an image of a pretty well-formed hand, and the prompt was a hand missing one finger. Yeah. And so there are several technical reasons why this happens. Let's talk about hands. It's a very non-rigid. There are many ways to see that, and it just doesn't understand that the hands has this physical structure. This is related to what I've shown before with the woman swapping it just sees patterns. It doesn't have a physical understanding of, an understanding of the underlying physics. And, the way people learn is very different. We interact with the world. When a baby, you probe things, you try them, you put them in your mouth, of course, as a baby. So you have a much better understanding of the physical worlds. And these models, you only show them few images. So they're much more limited in information they have access to.
I mean, that's a very interesting also philosophical question, really. However intelligent the machine gets, then, if it doesn't have this, what Heidegger called being in the world, this presence and involvement in the world, can it ever really be called sentient in a way that a human would understand?
Right. Yeah.
But that's for a whole other session. Another question I have here is, how, again anonymous, how might this technology generate recurring revenue streams, particularly in the education sector where budgets are often constrained?
I'm not sure I know enough to answer this question. Let me just say, I think there's a really interesting potential for education because there's a lot of data showing that if you teach children in a more personalized way, and if you catch them at times where they're interested, and we all know that from our children, they learn best when they ask the question rather than when you tell them. So here we have really potential for tutors that could give really interesting and useful
personalized
questions. Personalized. And of course we should do that very carefully, and there's a long path how to do that. Mm-hmm. But there's a real potential. I think people measured and show that if you learn in a personalized way, the quality of education really is boosted significantly. Yeah.
Now, a technological question. How could quantum computing affect generative AI video making, generative visual AI?
Yeah. So there's of course, large promise there. It's probably going to take quite a few years until this will become widely useful.
Quantum computing in general, you mean?
Quantum computing in general. One thing that we actually work on now is to use accelerated computing, GPUs, for helping quantum science. Because, again, often this is the idea of simulation. Using a quantum computer is very expensive. So if you want to develop algorithms or you want to develop systems, sometimes what you want to do is use a simulation of a quantum computer on a classic computer. And it turns out you can build clusters of GPUs that allow you to simulate what happens and then you can accelerate or make more efficient your quantum computer just using classical computers.
Okay. Now, Vasilis asks what your thoughts are on the applications of vision models for robots and autonomy systems in real time.
Yeah. So that's very interesting. And of course, I think there's a continuous effort to make vision model much more efficient, and we already see a lot of computer vision and perception running on more and more efficient devices at the edge, and it's really getting there. I'm not sure if the question was very specific, but you can imagine when you have a physical robot, you probably need several types of computing, right? You need something at the edge. You can also use kind of a backroom cluster that helps do the perception. And of course, you also need another computer to train the model, the robot in simulation.
Perhaps related, I have a question which harks back to the slide with the Thinking Fast and Slow, the Daniel Kahneman book. Which thinking system does AI use the most? Fast thinking or deeper thinking that requires more time?
Yeah. So this is one of the changes that happens. That this is related to your question about reasoning. We use to train AI systems like the fast system. This is a system that things pop to your right. You see a snake, you immediately recognize that. In more technical terms, if you have a deep network, you just take the input and you compute, and you do it once. So the term fast might be a bit misleading. It's more like constant time. Doesn't matter what the input is. It could be a hard question or an easy question. You just pass it through the network once. And this is what we used to do until pretty recently. And more recently, especially with LLMs, we start to go more and more into this system too. For example, as people show, you ask the LLMs, sometimes they have hard time solving a problem, and then you tell them, let's solve that, let's do that step by step. And just by the fact that they talk with themselves and write down their thought process, it turns out it's easier for them to solve. So,
like the way DeepSeek did it.
Yeah, I mean, this idea was happening much earlier. There's this chain of thoughts and tree of thought. And yeah, and we can now take that to a next level and open many more possibilities, many more options during the thought process.
Now, I have another question from Melissa Adamandidi about AI and the scientific method. She asks, how can AI be adapted to enhance creativity in scientific applications? What is the deeper thinking behind it, and how does its training process look like?
Yeah, so we are very early there. Let me just say, there are a lot of these questions are great questions that we still, in a phase of active research. But you could imagine, if you think about the scientific process, it has several components, right? There's a ideation. You just you raise hypotheses, you generate hypotheses. And you could help scientists. When I sit with students, I have some ideas, but maybe I think about 5, 10 ideas. I don't think about 10,000 ideas, right? So you can imagine a system that just generate ideas. Perhaps they look at the literature to see if this idea was already invented or not, and just show you some of these ideas. And usually what happens is it's not that the system will get like the great idea. The research shows that the systems are pretty good at novel ideas, but they are really novel. They're not feasible. So, of course, good ideas, they need to be novel, but also realizable. So clearly you want this interaction between the scientists that understand the full system and the system that propose hypotheses. And once you have these hypotheses, of course, you can get help with coding them. You can get help with analyzing the results. And of course, with writing the paper.
But so can it really generate novel ideas in this? Because obviously all the data it has is from existing papers. Have you seen something like where you're like, this is a genius idea? Where did this come from? Genius being, one way to describe genius is something really original.
Yeah.
Have you seen that from Gen AI?
I haven't seen that yet, but I think it's an interesting philosophical question. What is really original? What is really novel? And if you look at the scientific process, even today in science, a lot of advancements are not just leaps, but
they're incremental.
You have gradual. You have gradual. Of course, you don't hear about it, so suddenly you think there's a leap. There's also the other mechanism that you combine ideas from two different fields. And here, perhaps, these models can be useful because they know a lot about different fields and they are less narrow than...
And they can bring to bear the knowledge.
Perhaps they can bring ideas from one field to another.
Now, another questioner asks, they comment that it's becoming harder to identify real from AI-generated content. And they pose the following question: can AI itself help with the identification, separating the real from the artificial by spotting things that are not visible to human eyes?
Yeah, so definitely. AI is used to detect patterns that a person perhaps doesn't see. And you can train AI model on fake data, on real data, and they're pretty good at this. Of course, it's kind of, it's a battle, right?
Yes.
Always attackers and defenders.
Panos Frangos asks, which programming language is preferred for developing visual Gen AI?
We're using all the standard platforms today. It's Python. I mean, when we work at this high level. Yeah.
And another interesting question about moving from the digital to the real world. There's an anonymous question which asks, where is the benchmark set for deciding when to stop training an AI model in a digital, quote-unquote, playground and train it in real-life scenarios?
Yeah, that's a great question. Clearly, you want to have models of so perhaps if you have a factory, you want to generate a simulation of that factory and have all the physical environment, and then you train a physical AI in simulation, and you test it, and then of course when you deploy, you're going to do careful testing and safety testing. And I think we are approaching that phase. Currently, there are cases where people train simple robots for movement. Let's say you just want to train the robot to walk on the floor that is not even. You'll be surprised how hard this is, right? And if you train it on even terrain, now you give it some bumps in the road, it might be very hard for the robot. So these are things that are easy to test, and you can see the improvement from simulation to real.
Correct me if I'm wrong, but one of the things that seems to be more the case now than we thought of maybe 5 years ago is that some of the more intellectually taxing cognitive tasks now seem to be, the AI models seem to be more able to do them, and what's more challenging is manual jobs like, for example, a gardener, something like that, are less easy to mimic. Is that right?
It's true that a lot of manual work are very hard to automate. You know, our body is a really amazing mechanism. We sometimes, it's so easy for us and intuitive for us, but we sometimes don't realize how well we do things. Let me just give you an example. Every time you want to grasp something, often you don't see the other side of the object. And for a robot, it's very hard because for grasping something, you need to know its shape. And our mind actually has this world model. It completes, you have a prediction of the other side of the object, and then you can grasp. And we do that every time we reach to something, we actually have a very complicated prediction of how an object looks like. And then we have this close feedback. We need very gently to capture something. So we have this system that evolved for, you know, long time, and there are a lot of challenges in replicating that with physical AI.
We just have enough time for one last quick question from Iraklis Venduras. Are there any new developments in technology that will allow AI training to be significantly accelerated while also reducing the cost?
Yes, of course. I mean, everyone, we are trying to make things more efficient in terms of compute, in terms of power, in terms of energy, in terms of heat. That's our goal.
Okay, well, that's all the time we have for this amazing session. Thank you so much, Gal. And it's time for a coffee break.
Thank you.